Imagine a cosmic phenomenon so mysterious that it could change everything we know about the universe. A force so powerful, it might just explain one of the biggest enigmas in space: dark matter. What if white holes, yes, the theoretical opposites of black holes, held a secret? Could these elusive entities be the key to unlocking the mysteries of dark matter? Stay with us as we dive into this mind-bending possibility, and don't forget to like the video and subscribe to our channel for more cosmic explorations. White holes, a concept as fascinating as it is enigmatic, serve as the theoretical yin to the yang of black holes. Imagine a cosmic entity that, instead of pulling everything inward with an unstoppable force, actually pushes everything away. This idea first emerged from the same equations of general relativity that predicted black holes, but with a twist. Where black holes are points of no return, white holes represent the ultimate cosmic exit, spewing out matter and energy into the universe. To visualize this, think of a black hole as a drain in space, sucking in everything around it. A white hole, then, would be like the other end of that drain, forcefully ejecting whatever comes near. While black holes have been observed and studied extensively, white holes remain purely hypothetical, an exotic matter of theoretical physics that challenges our understanding of gravity and space-time. In the grand cosmic dance, black holes are the ultimate consumers, gobbling up stars, planets, and anything else unfortunate enough to cross their path. But white holes, they would be the ultimate givers, continuously pushing out matter and energy in a way that defies our current understanding of the universe. Now, here's where things get interesting. While black holes have been detected through their gravitational effects on nearby objects and the radiation they emit, white holes are trickier. They might exist in the same way a myth exists, spoken of in hushed tones, their presence suggested by tantalizing clues, yet always just out of reach. It's like a cosmic mystery waiting to be solved, a puzzle piece that doesn't quite fit, but could change everything if we could just figure out where it belongs. So, what's the big deal about these white holes, you might ask? Well, for starters, they challenge our very understanding of the universe. If they do exist, they could represent regions of space-time where the usual rules simply don't apply. Imagine a place where gravity works in reverse, where instead of pulling objects together, it pushes them apart. This isn't just a wild theory. It's a possibility rooted in the same physics that gave us black holes and the expanding universe. But here's the real kicker. Could these mysterious entities hold the key to one of the biggest cosmic puzzles of all, dark matter? As we explore this question, we'll dive deeper into the unknown, where the boundaries of astrophysics and theoretical physics blur, and where the answers might just rewrite what we think we know about the universe. Dark matter, two words that have fueled countless debates and sparked endless curiosity in the world of astrophysics. It's one of those cosmic phenomena that seems to lurk just out of sight, influencing the universe in ways we can observe but not yet fully understand. Imagine for a moment, 85% of the universe's mass is composed of something we can't see, touch, or directly detect. It's as if the universe is playing a grand game of hide and seek, with dark matter being the elusive player that always manages to stay one step ahead. Despite being invisible, dark matter's presence is undeniable. We see its effects in the way galaxies rotate, the way light bends as it travels through space, and in the very structure of the cosmos itself. Yet, for all its influence, dark matter remains one of the universe's best-kept secrets. The search for dark matter has taken scientists down some of the most intriguing and perplexing paths in theoretical physics. They've built detectors deep underground, hoping to catch a glimpse of this mysterious substance. They've studied the cosmic microwave background, looking for clues in the afterglow of the Big Bang. And still, dark matter remains elusive. Current leading theories suggest that it might be composed of exotic particles that interact very weakly with ordinary matter, making it incredibly difficult to detect. Others propose that dark matter could be something even stranger, like primordial black holes or other exotic matter that we've yet to discover. The truth is, we're still in the dark quite literally about what dark matter actually is. But here's where things get really interesting. What if the answer to the dark matter puzzle isn't out there in some distant galaxy, but rather tied to a phenomenon we've already theorized about: white holes? Think about it. If dark matter is something that doesn't interact with ordinary matter in the usual ways, could it be that white holes, with their repulsive gravitational effects, are producing or mimicking the behavior of dark matter? It's a radical idea, sure, but science has often advanced through such bold thinking. As we explore this possibility, we're not just peering into the darkness of space. We're delving into the very fabric of the universe itself, where the known and the unknown meet, and where the next big discovery might just be waiting. Now, let's dive into the tantalizing possibility that white holes could be the hidden source of dark matter. It's a theory that's as bold as it is fascinating, suggesting that these hypothetical regions of space-time might not only exist, but also be responsible for one of the universe's greatest mysteries. Imagine white holes as cosmic fountains, spewing out matter and energy into the universe. Could it be that this expelled matter doesn't behave like the ordinary stuff we're familiar with, but instead takes on properties akin to dark matter? If white holes are ejecting matter that we can't see or detect with traditional methods, this could explain why dark matter remains so elusive. It's an idea that turns our understanding of both white holes and dark matter on its head, and yet, it fits within the framework of theoretical physics. Recent theories have started to explore this connection, suggesting that the matter expelled by white holes could account for the gravitational effects we attribute to dark matter. Picture this. As a white hole ejects matter, this matter doesn't interact with light or ordinary matter in the usual way, making it invisible to us, much like dark matter. But its gravitational pull would still be there, subtly influencing the rotation of galaxies and the bending of light across vast cosmic distances. This could potentially solve the mystery of dark matter's invisible nature, offering a unified explanation that ties together two of the most enigmatic concepts in astrophysics. It's a hypothesis that requires us to rethink what we know about the universe, and it's one that scientists are beginning to take seriously. But let's not get ahead of ourselves. This is still very much a developing idea, one that sits on the cutting edge of theoretical physics. To truly understand if white holes could be the source of dark matter, we'll need more than just bold ideas. We'll need evidence, data, and perhaps even new ways of observing the universe. Imagine the technological advancements that could come from this pursuit. New instruments capable of detecting the faintest gravitational waves, or simulations that allow us to peer into the heart of a white hole. The journey to uncover this connection between white holes and dark matter is just beginning, and it promises to take us into uncharted territory, where the boundaries between known and unknown blur, and where the next great discovery might be just around the corner. If the connection between white holes and dark matter were proven, it would represent a monumental shift in our understanding of the universe. Think about it. If white holes are indeed the hidden source of dark matter, this would not only solve one of the biggest mysteries in astrophysics, but also rewrite the very laws of cosmology as we know them. Such a discovery would force us to rethink the nature of gravity, the formation of galaxies, and even the fate of the universe itself. The implications would be profound, touching every corner of astrophysics and theoretical physics. It would open new doors to understanding how the cosmos operates on the grandest scales, and it might even provide insights into the origins of the universe. Now, consider the ripple effects this could have on space exploration. If we can better understand dark matter through the lens of white holes, it might lead to breakthroughs in technology that we can scarcely imagine today. Picture spacecraft that could navigate through or even utilize the unique properties of dark matter, or perhaps advanced detectors capable of observing white holes directly. The possibilities are endless, and they stretch far beyond what we currently perceive as the limits of human knowledge. This theory, if confirmed, could become a cornerstone for the next generation of scientific discovery, propelling us into a new era of exploration and understanding. But let's keep our feet on the ground for a moment, because while the implications are exciting, they also require us to maintain a critical perspective. The idea that white holes could be the source of dark matter is still very much in the realm of theoretical physics, a field where ideas are constantly tested, refined, and sometimes discarded. Yet, it's in this very uncertainty that the beauty of science lies, pushing the boundaries, asking questions that seem impossible, and exploring concepts that challenge everything we think we know. As we look to the future, the pursuit of this theory will undoubtedly bring new challenges, but also new opportunities to understand the universe in ways that were once thought to be beyond our reach. Now that we've journeyed through the fascinating connection between white holes and dark matter, the question is, how will this new knowledge change your perspective on the universe? Could it be that the answers we've been seeking are not in the distant stars, but hidden in the very fabric of space itself? Imagine the possibilities if we could unlock the mysteries of dark matter, opening doors to new discoveries, and perhaps even new technologies. What will you do with this knowledge? Will you let it fuel your curiosity, driving you to explore further into the cosmos? Or perhaps even rethink what you thought you knew about our universe? If this video sparked your interest, don't forget to like, share, and subscribe to our channel. Make sure to turn on notifications so you won't miss out on our next exploration into the unknown. And speaking of mysteries, have you ever wondered if there's a hidden giant in our solar system? Check out our previous video on Planet X, the hidden giant that might be lurking just beyond our reach. Could this elusive planet be the next big discovery in space exploration? Click the link and find out. Until then, keep questioning, keep exploring, and keep looking up at the stars.